I'd like to welcome you to this 14th in the Wireless Innovation Forum's webinar series. Today's webinar is on the Wireless Innovation Forum's Advocacy Agenda. I'd like to introduce today's presenter, Bruce Oberlies, President and Chair of the Wireless Innovation Forum. And Bruce, I'll turn it over to you.
Thank you, Lee, and thank you for this opportunity to walk through the Wireless Innovation Forum Advocacy Agenda. We developed the Advocacy Agenda and released it in March of 2013. And the reason why we put it together was to help our members and regulators and others throughout the wireless industry understand what the Wireless Forum is advocating for in our positions and allow us to be faster on responding to regulatory events that are happening around the world. And our regulatory advocacy agenda is really there to support the forum's mission statement of advocating for the innovative utilization of spectrum and advancing radio technologies that support essential and critical communications. And our advocacy agenda covers 5 areas: essential and critical communications, innovation and competition, spectrum, security, and interoperability. And I'll be walking through each one of those and giving you more information. And first area we'll start with is essential and critical communications. And we defined essential and critical communications as systems where loss of communication can cause injury or death or lead to loss of civil disorder. And so as you think about that, you clearly see public safety is one of those essential and critical communications, but as well as defense and critical infrastructure. So there's a lot of communications that systems that we consider and look through as we advocate. So the forum is advocating for high availability, fault-tolerant, secure, and extensible system architectures for essential and critical communications. And as we look at the communications environment, the graph we have here, or the picture we depict, talks about kind of a continuum of what those systems may look like from a network perspective. On the far right is best effort, mass market, so traditional commercial carriers, where resource utilization is critical, number of users and capacity and efficiency. So they're designed to make sure that they get wireless data and voice to the masses. And on the other side of the spectrum is the public safety, where their focus is reliability, ensuring that the communications system is up no matter what the situation may be, power outages, significant storms and outages. And they also worry about coverage, where they typically have 97% coverage, area coverage, and even more. And they worry about making sure they have coverage in basements, underground garages, and other places where there may not be people, but there could be an incident. And so it's important to be able to communicate that area. And as well as security, verifying that the users are authorized and authenticated. And the points that are really critical about this is that from an essential and critical communications viewpoint, it needs to be an integrated architecture strategy. There cannot be a single point of failure. It really needs to be extensible. And another focus area is around interoperability. So it is critical for different public safety agencies to be able to come together and interoperate, as well as secondary users that are there to support first responders must be able to operate on the channels and interoperate. And as I mentioned before, just to enhance security, that the users need to be authenticated, they need to be authorized to use it, and there needs to be control over the radio channel to make sure that communications are happening when they're critical versus just random chatter that you might see in a commercial environment where people just want to chat on what they're doing. And as we think about this, what's really critical is thinking about it and defining the architecture around the users and the user's mission. So really understanding the user and the user's missions and understanding what the value proposition they bring, and then guaranteeing coverage and availability and reliability. So we see that the use of SDR, or software-defined radios, cognitive radios, and dynamic spectrum access is the best way to leverage commercial technologies and standards to meet the needs of essential and critical communication systems. What's critical here is multi-band service, or multi-band radios and multi-service. Here's an example of a graph where we may have multiple users that are coming together. They are likely to be operating on different bands. The federal radio users will be operating typically at a different frequency as what state and local. They may be operating on different protocols, so they may be using P25 conventional and P25 trunked radio systems. P25 is the standard in U.S., but it also could be Tetra, which is the Trans-European trunked radio, which is a European standard for public safety. And as those radios come together, having the capability of being multiple bands, so they can then come together and interoperate, whether it be a switch on the existing radio or whether it be in this depiction of this graph, a gateway that will be software-defined and multi-band and actually do the switching and do the gateway connection between those radios. What's important here is also open standards. As software-defined radios can be reprogrammed, they can be future-proof. So therefore, we want to be able to use open standards and operate in open standards, and I just named two from a public safety perspective. And then in the Department of Defense and tactical radios, there's a number of standards there for waveforms that they use, and the flexibility of the software-defined radio to operate across multiple bands and multiple protocols is really critical. One thing to be aware of is that all current public safety radios are really software-defined radios today, and as well as the tactical radio systems. Unfortunately, they're not all multi-band, but we're seeing the multiple manufacturers come out with multi-band radios for public safety, and of course in defense they've been multi-band for a number of years. The other thing to be thinking about when we think about software-defined radio, cognitive radio, and the dynamic spectrum access is that we need and see a need for having ad hoc networks. They need to be self-optimizing systems to fill in coverage, so there will be times when incidents happen where there's not coverage, or there may not be enough capacity in a spot and we need to bring in a system that allows us to extend the capacity, or to use other spectrum outside the dedicated spectrum that is there for extending the capacity. And we'll be talking about that in a few slides coming up. This is a picture that came out of a chemical plant scenario that was developed by the forum, our public safety SIG in the forum developed. And it's around policy-based radios. And what's really critical, what the forum advocates, is the use of dynamic situational prioritization of network and spectrum resources to optimize communications to meet the mission's needs. And the real essential part of this is when there are major incidents where priorities need to change, or public safety user focus changes from maybe report writing to when they are in a situation they need to have data coming to them quickly. They need to be able to ensure they can communicate. So in this graph, they show who requests the information, whether it be an individual responder, a central authority, or a network, and then who authorizes it. And they show multiple stages that can occur. And the blue areas is the future cognitive radio and cognitive network capability, where it is fully automated and capable of prioritizing the channels that are being used, identifying spectrum that's available to extend the capacity of the communication system at incident scenes. And there's a couple pieces that are important to think about this. The forum's has a modeling language for mobility paper that was developed on cognitive radio ontology, and it goes through and identifies how to express use cases and radio control between radios so that radios can be modified and updated through policies to enhance the user's effectiveness and efficiency. Let's see, is there anything? And the other piece I think that's really important, the takeaway is that ensuring when there's an incident, ensuring that the resources are available to the individual responders. So resources meaning spectrum that's available, or prioritizing the bandwidth and capacity to users that are in need. So imagine a user is out of their vehicle and they're moving into, maybe it's a firefighter moving into a building, wanting to bring video back to the incident commander. That user needs to have capacity, so the system needs to change its policies to ensure that that user gets the data and maybe pull data capabilities and resources from places that are not in need away from that incident. The other key advocacy that we have in this section on essential and critical communications is we advocate for the capability to dynamically access additional spectrum for essential critical communications. Major incidences and disasters are going to occur, and we're going to need additional spectrum, and the forum advocates, and we'll talk about this later on, exclusive spectrum for essential critical communications, but there will be needs to have additional resources and additional communication channels for the first responders and for, in this case, response, but also for military. And it's going to be critical that the users are capable of getting additional spectrum to use that. And in this example, we have multiple agencies that are coming to a scene. They need to be able to, number one, have the security in place to be authorized to pull down the policies and use it, but also to have the incident commanders identify what spectrum is to be used and prioritizing who is using what spectrum to make sure that they can communicate when they need to communicate. The other point to point out here is the PCAST report that was released on realizing the full potential of government-owned spectrum, points out the need for sharing of spectrum. And the 3.5 gigahertz work that's going on in the U.S. is a good example of work that's going to make this happen. We're now going to move into innovation and competition and the forum's advocacy in these areas. The first point is the forum advocates for government strategic investment of joint research and development between industry and academia, in particular to address the needs identified in the Wireless Innovation Forum's 10 Most Wanted Innovations list. The forum updates its 10 most needed innovation areas once a year, and recently Bob Schutz did a webinar on our 10 most wanted technologies. And in this case, it's not only technologies, but it's also regulatory needs as well as business needs. So we focus on what are the innovations, whether it be technology, regulatory, or business. And so I strongly suggest that you go to that. And a number of people are using our advocacy agenda to go off and justify the needs on moving forward on investment for government funding. The forum also advocates for the establishment and utilization of real-world spectrum test beds and test cities to mature and validate cognitive radio and network technologies. And the key here is that, you know, we do a lot of research in this area in very controlled environments in labs, but really progressing those out to the real world and getting the real world understanding and performance is going to be critical to create confidence in those who are incumbents to ensure that they will not be interfered with, but also to help the manufacturers and developers have confidence in their technology and reduce that risk that they can come out with a strong business case. And the forum believes the focus points that we need to have around spectrum test beds and test cities is to validate the capabilities of cognitive radio, so being able to go out and validate cognitive radio capabilities. We need ways to reliably identify harmful interference and validate that the technology is really mitigating those any potential harmful interference, and that creates the confidence in the incumbents and confidence in the new communications providers. We need to be able to measure spectrum efficiency, and we need to determine ways to increase the spectrum efficiency. And so as new academia as well as research and development groups identified new technologies and new capabilities that improve spectrum efficiency, we need to be able to measure that and validate that in the field. We need to be able to have confidence in being able to investigate new technologies, so we got to ensure that these new technologies can be tested and they can fail in the field, and we learn from those failures and improve upon that. And we also want to validate the potential, the value in the business cases. So they need to be put in the real world use cases and be tested to validate that they meet the performance and user criteria that the business case has been put up for. The most important point of this is it needs to be controlled and repeatable. So we to build confidence in both the regulatory world as well as the business world, we need to be able to control these real-world test beds and repeat it. And we believe that these need to be government-sponsored with funding. And a good way to go through that is with CRADAs or corporate research and development agreements, so that we can move those forward. So we advocate, and we believe this is very critical to allow us to speed time to market of these new technologies that's going to improve spectrum efficiency. The other point we advocate is the use or the easy access of experimental spectrum licenses for industry and academia. We need to be able to move quickly to get and have the regulatory bodies allow us to move quickly and flexibly to accommodate unique situations that's going to occur as we go out for real world test beds. Today, sometimes the systems can be onerous and take time to get the spectrum available or the test channels available to go do that. And we believe that this needs to be simplified around the world so that the research and development teams and academia can go out and validate their technologies. The forum also advocates for minimizing regulatory barriers to entry and promotes technical innovation, enabling incumbents and entrepreneurs to pursue new business opportunities throughout the wireless chain. The market is today is really driven around fixed channels, and we believe that the regulatory policies need to be changing to be market-based, and we believe that we can overlay new policies and technologies on existing licensing schemes across multiple bands and wireless services. Versus today, they're all static allocations, and by using a market-based methodology here from a regulatory policy, we can move forward and become much more spectrum efficient. And so the forum's advocating also the establishment of new dynamic rules that allow advanced wireless devices to operate across wide swaths of frequency bands on temporary, cooperative, and opportunistic basis. And of course, that has to be within the RF environment so that we can ensure that the incumbents there's no harm to the incumbents. And this is really our innovation number 10 that Bob Schutz talked about. And so this, we believe, is a critical thing, and we're going to spend more time talking about spectrum in this next section that we'll get into our thinking on the regulatory side. So spectrum is going to be broken up into 3 segments: regulatory, technology, and standards. And we'll begin with the advocacy points that we have on the regulatory section for spectrum. And I apologize, there's a lot of words here, and strongly suggest that you go to the forum website to read the document and get the details here, because each one of these bullets have several paragraphs to support their points. So the first point is the forum advocates for dedicated spectrum for essential and critical communications. First responders, state and local, federal, homeland security, defense, require immediate and prioritized access, and we believe that can only be met through dedicated spectrum. So where we believe in, and I'll talk later on additional shared spectrum, we believe the dedicated spectrum is still needed, and that we don't want to move away from that. We also believe that commercial as well is going to need some dedicated spectrum just to validate that there's a business case and give them a predictable understanding of what their business case looks like. So there still needs to be a future of some dedicated spectrum. The forum advocates for technology and service neutrality to enable innovative and efficient use of spectrum. We do not believe regulators should mandate what the technology that should be operating in any of the dedicated spectrum areas. Today, there are still regulators that require commercial wireless operators to use GSM in certain bands. But today, with the software-defined radio base stations that we have, and as well as the software-defined devices, there's no need to have the regulatory bodies define the type of protocols that are being used within that spectrum, and allow the market to decide what's the best way to do it and what's the best way to move forward on introducing new technologies. The forum advocates a regulatory model that includes combinations of licensed and unlicensed, sharing and hierarchical, cooperative and coexistent domains for optimal utilization of spectrum. So this is what I was talking about earlier, of overlaying on top of the dedicated spectrum models that allows us to add unlicensed and sharing and hierarchical type of capabilities. So yes, we need exclusive, but we also need to have this capability of doing that. And I'll talk more about this when we get into the technical areas of, we believe the technology is there that allows us to have a regulatory model that includes both licensed and licensed. And I would say the FCC recently with the 3.5 gigahertz FNPRM is a great example of both the NTIA and the FCC looking at how to go off and look at a regulatory model that incorporates this. And the forum believes that reallocation of spectrum is not a sustainable basis for sound spectrum policy. And this was also brought up in the PCAST report that I referenced earlier. There's a high cost, and it takes a long time to move and reallocate spectrum. A great example is just looking at how long it took for the TV rebanding and rebanding the spectrum to open up new spectrum for LTE commercial services in the U.S. as well as public safety broadband services capability in the U.S. And they opened up TV white space areas, but that took so long that it just slows down the viability of new solutions and communications capability we have. So we believe that you cannot do that in using shared technology, shared spectrum capabilities on top of an existing license area is the best way to do it, and then slowly move it out of move out the incumbents out of that spectrum if that's the best thing to do there. They will find the right place to go. The forum advocates allocating spectrum with licenses adopted towards a spectrum usage rights method that has the minimum necessary technical restrictions to provide adequate protection against harmful interference. The optimal use of spectrum is more likely if the market and not the regulatory agency decides what the technology or service is. And so this aligns nicely with the earlier point that we made as far as the network neutrality or the service neutrality point on 3.1.2 that we had. So again, with the software-defined radio capabilities and with cognitive radio capabilities, there's really no need just to drive to a specific technology restriction. We just need to be focused along the lines of how to best regulate the spectrum to minimize harmful interference between the incumbents or between the existing future users of the spectrum. And that's where the regulatory agency should be focusing. The forum advocates unified active management of spectrum, terrestrial, aerospace, and maritime to maximize spectrum utilization. So TV white space as well as the 3.5 gigahertz has used databases to go off and identify what the spectrum utilizations worked on, and that'll be a point we'll talk about in the technology area. But we believe that databases, spectrum databases, is the right way to manage spectrum going forward and to help maximize that utilization. Understanding who's using it, what are the time openings that are available, and prioritizing it future-proofs that spectrum utilization in the future. And lastly, the forum advocates the use of receiver characteristics as part of the analysis of spectrum allocations. For a long time, the world has been, and regulatory bodies have been focused on just the transmitter characteristics and have not looked at the receiver characteristics. But as we look at improving the efficiency of spectrum and pushing users and minimizing the amount of guard band, understanding how the receiver operates and how it can, the characteristics of the receiver and respond to the transmit energy that's in adjacent band is very critical. And as we move forward and we want to get more spectrum efficiency, we're going to have to look at the receiver characteristics, and we're going to have to drive towards continual improvement. A great example, and we'll cover it later when we get in the technology section, is when we looked at the GPS band and trying to, light squared, trying to use some spectrum right below GPS, and the GPS receivers have been very static in their performance because they did not anticipate someone using spectrum just below them, and we were not able to use that spectrum because the GPS would be harmed. So we really advocate the use of receiver characteristics, and we actually have a receiver specification project that's actively going on in the forum to work on identifying this. And in the 3.5 gigahertz proceedings, there's a lot of discussion on a multi-stakeholder group, and the forum has raised its hand to host a multi-stakeholder group. And one of the areas that the multi-stakeholder groups would be focused on is identifying the receiver characteristics and specifications and standards around that. The next section, as we're talking about technology or talking about spectrum, is technology and how to enable spectrum utilization, better spectrum utilization through technology. And the forum advocates for further research and development of technologies that will improve utilization of both managed and unmanaged spectrum. And so the first spot we will talk about is forum strongly supporting the use of networked and synchronized databases assessed with the device location information. And the point we are showing here on the right is two radio systems with a database on the far right that's collecting information from two different devices, providing their current environment information that they've captured and sensed, looking at the policy that they have internal to their radio, as well as the policy that's defined in the database on how long they can operate, providing the location that they are at so they can come back and let the database operator know who they are, where they're located, and understand who the potential incumbents are in that area and what frequencies available. So databases have been identified, and the FCC has moved forward, as well as Ofcom, with use of databases. They are adaptable. They are essentially a future-proofing capability. So as interference gets identified, we can block out that area and provide trust for the incumbent for not having to have future interference, because we've identified that there's a potential interference spot from at that potential spot. As well as it allows us to gather real-time spectrum information and awareness to start stitching together a spectrum database or a spectrum model. And in this example, you can look at it from a cooperative sensing. So if I am just a single radio and I'm just sensing my environment, there are hidden node risks that occur where I may be blocked by a large building or something else, and I can cause interference and not recognize it. But with the cooperative sensing, where I have multiple RF units that are around, providing that information back to a central database, the information and the mapping of the spectrum use in that area is better, and we can prevent the interference. We can also improve the sensitivity of the sensors. As you have multiple sensors there, the inherent sensitivity will improve. Lastly, the forum advocates for spectrum sensing technologies to better enable cooperative opportunity access, and recommends that advances in spectrum sensing technologies not be discounted in the future regulatory and system planning. In the TV white space proceedings, there was a lot of work looking at the capability at that particular point in time of sensing, and at that time sensing was not good enough and give enough confidence to the FCC to moving forward. But we believe that it will get better, and that it's important to not prevent that from happening, and to really encourage the cooperative sensing, bringing that back into a database, because we believe that that will provide the best system and the best spectrum efficiency, because of the understanding the RF environment versus modeling the RF environment. The forum advocates for the use of spectrum sharing and small cell technologies. So clearing and reallocating, as we talked about before, federal spectrum is not going to be sustainable. But as the PCAST report pointed out, spectrum sharing is an opportunity that we can go forward with, and is the best way to improve spectrum utilization. Small cells can also be used. So with small cells, we can put those cells close to where the users are needed. We can lower the power and allow us to do fill-ins, and that is a critical point that is an opportunity going forward. And our Cognitive Radio Working Group developed a paper, and it was called Quantifying Benefits of Cognitive Radio Technologies. And there they talked about the use of small cell technologies, as well as other capabilities and benefits of cognitive radio. And I strongly suggest you go to the website and look at that paper and get a better understanding of other cognitive radio benefits. As well as the Public Safety SIG did a report and looked at benefits for public safety on sharing spectrum. and found that it was a critical opportunity for public safety to fill in where they may be in a spot where they need additional capacity, and the dedicated spectrum will not provide that capacity, but there could be spectrum that they could use, whether it be licensed or unlicensed or lightly licensed, that they could do that sharing and increase their capacity in those incidents where it's needed. The forum considers spectrum etiquettes as an important regulatory tool for maximizing the economic and social benefit of the electromagnetic spectrum. And the forum also advocates legacy users augmenting their existing systems where possible to facilitate cooperative sharing of spectrum. And I tie these together. You know, there are principles and means to create a fair and efficient manner, as well as if legacy users start providing information beyond the transmit power and the frequency and location, but actually start providing information about the transmitter performance, what's the transmitter characteristics, the out-of-band energy they're transmitting, as well as the receiver characteristics. That enables the capability of building a spectrum dashboard that allows systems to maximize the spectrum efficiency. Today, spectrum development is defined on less than ideal receiver performance, and matter of fact, they design towards worst case. But as radio legacy users start showing what their capabilities and how they improve, we could look at trying to pack in more users into a small area and verify and mitigate that harmful interference because we understand how the receiver performs. So now we move into the standards on spectrum. So the forum considers harmonized standards to be an important stepping stone towards broad deployment of wireless communications. Benefits are for the wireless value chain. Clearly, developers have minimal risk in product development with the harmonized standards. Manufacturers can have a single set of requirements, and that allows them to have a broader customer sets of customers to manufacture products towards. Network operators have more manufacturers and more customers to provide to. Consumers have more manufacturers to choose from, and investors can have a bigger market and lower risk. So harmonized standards are important to bring in a broad deployment of wireless communications. And the forum advocates the use of existing and emerging transmit, receive, and interference regulatory standards to facilitate the use of spectrum system interfaces that enable a wide range of spectrum sharing opportunities. The new regulation should enable and encourage innovation in commercial and mission-critical communications. And having a well-defined and enforced regulations is important to do no harm to legacy users. And here we need to really, again, move from a transmit power world where we think about static designs to adaptive. So how can I have my transmitters be adaptive, and if they know their location and they know who they're transmitting to lower their power as much as they can. Perhaps they could, if they understand the receiver characteristics of the other people in that area, they could change their power levels to reduce that information. As well as from a receiver standpoint, we need to have understand and characterize those, and I just remind you that we do have a forum project that we would, if you have an interest in this area, we would love to have you help us on working on the receive standards. And lastly, on this point on facilitating use of spectrum system interfaces, using a spectrum consumption model or a model based on spectrum management where we have multiple users coming together, we have multiple databases. If we understand and harmonize on these consumption models, we can minimize the interference and do no harm to the legacy users. And so by harmonizing all these standards together, it will improve the spectrum efficiency. And lastly, we get into the role of receiver parameters and standards and how critical they are in spectrum engineering to make sure that we minimize the harm to users. And here's the example is if we look at the light squared and the fact that GPS radios haven't been designed for recognizing that people could operate and they have a wide open receiver. And here there's a lot of spectrum that could not be used because of that. And this is a thing that's important, recognizing that receives performance is a fundamental role and that it is continual receiver capabilities are continually improving, and that our radio designs and our regulatory bodies need to be considering these receiver parameters. There's also no real economic penalty for improving receiver performance in new products, and I would argue that if you don't continually improve the receiver performance in new products, you create economic harm later because you have to start working on interference problems that you had not had before as spectrum gets reutilized. An example would be in the U.S. on cellular A-band moving from 2G to a 3G, and so it's going from a relatively narrow band to broadband. The intermodulation changes and the OOBE interference is right next to public safety, and if public safety radios did not change from their learnings from the Nextel interference that happened, then they would start seeing those same interference problems when the cellular providers and cellular A change over to these new technologies. So radio manufacturers, research and development need to continue to work on improving the receiver specifications and the front-end filters. And this is one of the areas of our top 10 innovation list. This is one of our top 10 innovation points. Moving into security, the forum has published a report on securing software reconfigurable communication devices, and it identifies the processes and policies that specify criteria and measures for protection and mitigation throughout the system lifetime. And the forum believes that you need to be you have to consider security throughout the design, the development, and deployment of the systems for essential and critical communications. You have to understand the different threat classes, but we believe if you focus on security throughout the design and development, you can develop a very secure platform that can have a very long life cycle. And so we strongly recommend that you look through the number of reports that we've put together on security considerations. The next two areas we talk about are from some FCC petitions or some FCC report and orders that went out in, earlier in 2000, I think it was, in the mid-2000s. And so the forum advocates that the regulators focus on development applications of policies and standards that enable communication systems and platforms to protect all sensitive information and data. The key point here is that the FCC was pointing out that the manufacturers should not be putting out in the public the security measures that they put together in their software-defined radios. And this is really security by obscurity. And the forum believes that you should be putting out the security framework and have that out in the public so it can be reviewed and challenged and improved upon. Now, there are important things that need to be hidden, so clearly keys and passwords and biometric data has to be kept secret, but it's important to put out the security framework, and so we do not believe regulators should be telling manufacturers and others to not release that information to others. And also the other point we have is open source security. So the forum advocates regulators to adopt a neutral policy on security of open source elements, because these elements are a priority, no less secure than priority approaches. And this kind of responds back to the FCC saying that there would be a higher burden to demonstrate if a manufacturer would use open source. But again, open source is out in the public, and there are a number of open source security protocols that are used through banking and others. So we believe those are very important to go forward. And the forum advocates regulators allow over-the-air software reconfiguration of software and radio platform operating parameters. And the forum, again, has published a series of documents on securing software-defined radio. Security mechanisms exist that enable secure transmission of policies and reconfiguration data, and we're confident that as long as the security systems considered throughout the development the development cycle early on, that the software-defined radios and cognitive radios can be secure and reprogrammed or reconfigured over the air. And so we advocate regulators allow that to happen and occur. Next section we're talking about is on communications interoperability. The forum promotes standards, technologies, and regulatory policies to enhance interoperability and coexistence among essential and critical communications. And the forum is continually investigating wide varieties of interoperability techniques using software-defined radio and cognitive radio technologies. And so the areas we're going to talk about is openly developed industrial requirements and standards. So the forum advocates use of openly developed industry requirements and architectural standards that lead to interoperable products and standards. Open standards develop, foster a fair and open competition. It helps commercial providers leverage their technology better. It stimulates technology insertion over the standards life cycle, ensures the interoperability, and so that we believe that's an important piece. And we also believe the use of architectural standards is proven to facilitate significant software reuse, driving down time to market and lowering life cycle costs. And a good example of that is the SCA, or the software communications architecture, that was developed within the forum, and that has used across the defense and tactical radios, and it has allowed a lot of reuse of waveforms and software, and there's been a number of papers that have been presented in the forum's tech conferences that have shown that the amount of reuse and the economic value to manufacturers and research and development on these architectural standards. The forum advocates interoperability. The forum advocates interoperability innovations enabled by software-defined and cognitive radio technologies native to end-user equipment and systems. So again, interoperability can be expanded with wide spectral range of RF front ends, which is our top 10, one of our top 10 innovation lists, and as well as the smart gateway devices using cognitive radio, which I showed earlier with the public safety software-defined radio. So policy-based radios is another area that we believe is critical for interoperability innovations. And so these are points that are part of our top 10 innovation lists. And again, I recommend you go back and look at the webinar that Bob Schutz has done. And lastly, the forum advocates a top-down methodology, including the development of use cases for identifying technology gaps for any wireless technology study. This was a method that was used by our public safety SIG for the public safety interoperability use cases for both the London bombing as well as the chemical plant explosion. And they started with understanding what the use case was, how the users are going to operate, what their missions were, and then it allowed them to then identify technology solutions and how to leverage software-defined radio and cognitive radio. And I recommend that you go back and look at both the London bombing and chemical plant explosions to have a better understanding of the value propositions for both software-defined radio and cognitive radio for public safety. And that ends the overview of the advocacy agenda.
Thanks, Bruce. Appreciate you making the presentation, and at this time we'll end the webinar. So thank you very much for everyone for participating, and we'll look forward to attendance at future webinars.